Well, hello everyone. Welcome back to the Tin Barn. I'm Pragmatic Lee. Today we got a little project dealing with the mill. I'm standing behind my mill now. It's a Precision Matthews 727. Seen it in practically all of my videos, but I've had several comments, inquiries about the lift that I have for the head on this mill. This mill originally came, as is the case with most of these benchtop mills, came with a hand crank here, which when you're old like me, your shoulders aren't the best in the world, cranking that up and down kind of gets old. But in any case, I've got a friend that I originally met through the Precision Matthews users group on hobbymachinist.com. We got acquainted there and then got acquainted through Facebook. And he's got the same mill as this one, and asked if I could assist him on putting together a lift for his. I've got all the parts round up. Tony ordered all the parts, sent them to me. I'm going to put the pieces together for him. I've got access to a welder and got a little bit of electrical background, so I'll be able to wire it and all for him. Then I'll ship it off to him. He's in the western part of North Carolina, and he'll mount it. And hopefully, before this video is published, he'll be able to send some pictures back of it mounted on his mill. But basically what it does, flip the up switch. As you can see, the head is moving up. It's not a speed demon by any means, but it's about the speed of a normal crank if you were hand cranking it. It's been a lifesaver for me. Biggest inconvenience is having to reach over the table to flip the switch. So I'm going to turn the camera around to the bench, show you the various pieces, and give you an outline of what we're going to do to put these pieces together to create a power lift for this mill. All right, this is going to be a quick overview of what the parts that we need for this. This, of course, is the most important part. This is a gear motor. Purchase this. These are used. This one is used. The one on mine is identical to this. These were pulled out of service, have no idea where, bought them from a guy on eBay, and I'm sorry to tell you, if you're looking to do this project, between Tony and myself, we've bought all the guy had. This is my third one, and he bought one. I'm not sure who else might have had some, but the last one I purchased, he said it was his last one. But I'll give you an idea of what's on this. Something a little smaller might work, something a little bigger, of course, would work. This just happened to be what I stumbled across and what I settled on. These are Bodine Electric Company out of Chicago, Illinois, gear motor, 24 volt DC, draws 3 amps, 1/15 horsepower. It is RPM of 67. A little higher RPM might be nice to raise and lower a little faster, but again, this is what I stumbled across and found on eBay, so it's what I settled on. This has a torque of 42 inch-pounds. I don't think a windshield wiper motor or a car seat motor would have the power necessary to raise and lower that head. If you have a mill that has the hand crank on it, you know what I'm talking about. It takes some pretty good torque to turn that handle. So that's the gear motor itself. Now for the 24 volt DC, of course, you'll need a power supply. These were found on eBay as well. Just search for a 24 volt DC power supply. The one I'm using on my setup is actually from an old telephone transformer. It's a power supply that went with a phone system that I salvaged some time back. But this is one I have temporarily hooked it up to the gear motor, and it works fine. And what this video will be concentrating on mainly today is the mount. This is just simply a piece of 4-inch channel iron. On the end of this channel iron, we got a piece of 3-inch by 4-inch by 1/8. Well, no, that's 3/16 thick flat steel that I'll weld onto the end of that flat bar. There'll be a couple slots on this. This is what will be mounted up against the mill itself. Only 2 holes will be necessary to be drilled in the mill, and that will be to mount right here. On top of that will be a plate that the gear motor itself will mount to and hang back in this direction. This plate will be down here. The gear motor will hang back here and the shaft here. And on mine, I welded that up, but I'm a little reluctant to do that to one that I don't have the mill right here in front of me, because there may be a little bit of difference in the length of the shaft on sticking out of the mill on mine versus Tony's. So what I'm going to do is use a piece of 1-inch angle down here. Again, it's 4 inches long. It will be bolted to the upright plate, and then in here we'll cut just a couple of slots, maybe 1 inch in each direction from of where the distance of mine. I can't imagine the shaft being more than 1 inch plus or minus. Then we'll do the electrical part of it. So to begin with, we're going to lay out this plate right here for the hole pattern and shaft that's on the end of our gear motor. Alright, I've got just a quick little drawing here, but the center, the shaft on our gear motor has a housing. Well, the housing for the shaft has a little boss on the end down here. That boss is 1.32, and of course we want it in the center on the y-axis, and on the x-axis we want to come down 1.1 inch. I've got that laid out now, so what we're going to do is drill this. I'll step drill it up to 1 inch, then put the boring bar in and bore out to 1.32. That diameter is not super critical. It's just we just want it big enough. We want to know that it's big enough for our piece to go through, for our boss to go through. Alright, I have the DRO set on 0 now, so I'm going to move it out on the x-axis and do a test fit. It should go through there though. Alright, that shaft is too long to actually do a test fit, so what I'm going to do, I'm not going to move the y-axis, and I have this edge lined up with the edge of the jaw, so I'm going to go ahead and remove it and be sure it does fit in there. Which it does. Learn to trust my measurements. Now what I've done is I've taken the long bolts out and put some short bolts in, and I've got it bolted in across from each other. I don't want to take this head apart, but I'm going to carry it over there to the workbench and put this on there and center punch 2 of the holes. Then I'll run the bolts through that, take these out, and center punch those 2. Okay, I carried it over to the workbench, set it in there, lined it up, and center punched 2 of the 2 holes, mounting holes across from one another. And those are 1/4 inch bolts in there. I'm going to use a 17/64 drill bit just to give a little bit of leeway. I've put the long bolts back in those, in the mounting, and they line up fine now. So what I need to do is remove these bolts and using the center punch, transfer punch, Okay, now we'll take this out, put all 4 of the long bolts, mounting bolts in there, and be sure it all lines up. Okay, our mounting plate fits on there fine, but as you can see, these special nuts that's on there, extension nuts, the bolt on them is not quite long enough to come through. So we're going to set this back up in the mill, and we're going to mill out a pocket on each of these 4 mounting bolts here, a pocket big enough for the nut to go on and a socket to hold the nut. Alright, I've got the piece flipped over now, back in the vise, and so we can mill out for these, mill out some pockets for the mounting bolts. But as you recall, to mount this on the base itself, swing around here so you can see, to mount this upright piece that we just made to this base down here, we're going to use a piece of angle for this one. So while the drill chuck is still in there, I'm going to go ahead and drill those 2 holes and we'll drill both pieces together. And I'll be using quarter 20 bolts for pretty much all this project. Alrighty, I'll get an end mill set up now, get the drill chuck out and get an end mill set up, and be right back. Alright, excuse me, as I said, we need a pocket on here for the so that the nut can be tightened down, and the size of that pocket just needs to be what the head of a quarter 20 is, and a socket that will go in there. So to line that up, I'm just going to drop a bolt in there, set that in, and simply by eye line my mill up with that. I've got it set up on that one, and I'll zero out my DRO. And the purpose of that is knowing that I've got enough room all the way around for that. I'm using 11/16 end mill on this. So I'll remove that. Come down and get my mark. I'm going to actually come in from the side now. I'm not going to try to mill straight down, because on the ends here it will get the edge as well. So I'll set my Z-axis DRO. We're going to want to come down 250 thousandths, a quarter of an inch. And that's all the Y travel I've got. So I'm going to have to ease that down into it for this front one. Alright, I think I may be out of coolant. I'll be right back. Okay, I'm just going to have to keep plenty of oil on there. I'm going to have to mix up some more coolant. Okay, that was the zero on the DRO. I'll continue this process, just going down about 50 thousandths at a time till we get to 250. I'll go around and do all 4 holes. Alright, I'm on my last cut on the last hole now. And everything cuts so much better when it's cool, so I stopped long enough to mix up some coolant. Got some deburring to do, but what we have now is our full mounting plate, the recessed holes, and of course our 2 holes down here for the track. So I'll get that cleaned up. Alright folks, I messed up on one of the videos on here for this section. This is the base that the power lift was set on. All this is a piece of 4-inch channel iron. This was a piece I had laying in the in my scrap pile out there. It's kind of pitted, but it should work fine for the for this purpose. All I did was set this in the mill vise and mill out 2 slots. As I said earlier, I'm not going to weld the upright to this. I'm going to put that in with slots. Piece is about 6.5 inches long, and these slots are a little over a quarter. They're 7/16, 2.4 inches apart from one another off the center. 1.2 off the center, 2.4 between them. Okay, here's what we have so far. We have the base with the 2 slots we just cut. We've got the mounting bracket, vertical mounting bracket here with our hole in the center and our 4 mounting bolts coming through and recessed in. What I have back here in the vise now is the face plate that will go, see if I can back that up just a little bit. Face plate that will go on here. It will actually be welded on to this. That'll be the only welding necessary on this piece. It'll be welded onto here and will hang down, and there'll be a couple slots in it as well, and be 2 holes drilled into the column of the mill to mount through that, and that's what will mount this to the mill itself. Alright, so just like the slots in the base, I've located a center on this, and we're going to go our same 1.2 on each side of Y, each side of 0 on Y, just to keep things consistent. Actually, I think I'll make that, yeah, 1.2 is good. And then off of center on the X, we're going to go a 1/2 inch each way. This doesn't have to match anything. We're going to drill the holes in the mill column to match that. So we'll go a 1/2 inch each side of X, 1.2 each side of Y. Now, just like we did on the base, I'm going to go 10 thousandths each side on my Y, just to give a little clearance. Now we'll go to 1.2 on the other side of Y, other side of 0 on Y. And we'll plunge down again. Alrighty, I'll get this piece welded onto the base, and we'll probably be ready to start on the electrical portion. Alright, I took the last piece there that we saw, the piece of flat bar, welded it on the piece of the end of the angle iron, put a couple slots in that too, and we're going to bolt that onto our whole assembly here. We're just about finished with this project. Okay, I just have that snugged up for now. I will actually take that back off of this to ship it. But here's what we have. As far as the electrical is concerned, I have in another video, in an earlier video, detailed instructions on how to wire a reversing switch for a DC motor. So I didn't try to video any of that in this. And the power supply is simply an on-off switch on this side. See if I can turn it. So we have the power supply on and off here, and the lift up and down switch on this side. The power supply itself, like I showed you in the beginning, all I did was mount this on a piece of sheet metal that I had. It had a hole pattern in the bottom of it, so I just copied that. And I put a little bend in this piece of sheet metal right here, just to make a little cut. On the back of the mill that this will be going on, there's an access plate back there, and I'll have the user this is going to just to loosen the top screws on that access plate, drop this down over the access plate and tighten them back down, and that will be actually behind the column, so it'll be free from chips and coolant or whatever else may be flying around. But we can plug in our power supply now. hit the on switch. Power supply has a little green pilot light down in it. And then you'll see the rotation counterclockwise for up and clockwise for down. To mount this to the mill itself, the only thing Tony will have to do is probably need to get someone to help him hold it to begin with, but will be to measure from the center of this shaft down to the approximate center of these holes. Mark that on his mill. Take the handle off the mill, mark that same distance down, drill 2 inches from center underneath, drill 2 holes directly underneath the shaft, 1.2 inches apart, so it'd be 2.4. Try to keep that consistent up there. Drill through that and drill through the upright column and mount that on with a couple of 1/4-20 bolts. Then to attach the shaft on the mill is 15 millimeter, and this is the half of the Lovejoy coupling that will go on the mill. The shaft on the motors are 5/8, so that will be mounted onto there. Bushing in between, and then this will be on the shaft on the mill itself, and they'll need to be in reasonable alignment with each other, but this rubber bushing in there will take care of any out of tolerance or out of alignment that they might be. Thank you for watching. I appreciate it, and we'll see you on the next video.